All right, so let's look at our next algorithm. And the next algorithm is going to be an algorithm for searching through the list. So we'll call this algorithm, we'll call it find. Now the find is going to need to know where to start from, where the first node is. So for find, we're going to need it to have access to the head reference, the head pointer, the head variable. And we're also going to need to know what the target value is, what we're searching for. All right, so this is going to be a variation of a linear search, if you're familiar with that. So let's look at a couple of pictures here, a couple possibilities of memory. We could have an empty list where the head reference is just set to null, or we could have a non-empty list. So I'll just draw up one of those. So this is a list that has, say, 4 nodes in it and 4 integers. The actual integers in each node don't really matter for this example. We're just going to assume there's some values, and then I'll put a number 6 in here, for example. So what are we going to do? Now, we can never use the head reference for doing traversal in cases like these, because the head reference always has to be set to null to indicate it's an empty list, or it needs to be set to the memory address of the first node. It needs to know where that first node is. So we're going to need to use a temporary reference, a temporary pointer, temporary variable that's going to be set to contents of our head reference. All right, so what's the next thing that we're going to do? We're going to have to go node by node by node and check each node to see if it contains the value we're looking for. All right, so if we do that in our second picture, then we end up with a situation that looks like this. Okay, now let us say that I was searching for 6. So my find algorithm would need access to the head reference and the target value. So what are we going to do? We have to go through each node one by one. So that indicates that we're going to need ourselves a loop. So while what? Well, if we go and check each node and we say, well, do you contain 6? No, let's move to the next node. Do you contain 6? No, let's go to the next node. Do you contain 6? Yes. So we will have found our value, and so then we can break out. Maybe we'll return true. But let's say we're looking for 2. Is 2 in the first node? No. Is 2 in the second node? No. Is 2 in the third node? No. Is 2 in the fourth node? No. And so we've looked at every node. We don't have what we're looking for. So maybe we'll return false to indicate that we haven't found what we're looking for. But we're going to keep going so long as P is pointing at a node. If we go through all of the nodes, eventually P will be pointing at null. And that's when we will terminate our loop. So while P does not equal null. So long as that is true, we're going to check the contents of our node. So remember that we said that our nodes for this discussion are going to contain an integer variable named x. So we'll check x to see if it equals our target value. If it does, then we will return true. Otherwise, we will move on to the next node. So we'll update the contents of P with the reference in the node that P is currently referring to. We get through the entire loop, the loop terminates, and we didn't find what we're looking for. So in that case, we will return false, or whatever value is appropriate for your application. Okay, so let's test this. Let's test the empty list, scenario 1. Does our algorithm work here? First step, set P to H. Now we go to the second step, our while loop. Is P not equal to null? No, it's not equal to null. So it is equal to null. So this right here, this test expression evaluates to false. So our while loop is over, and then we return false. That's exactly what we want. Now what about in our second scenario? Right? So we'll say A, the value that we're looking for exists. So we're searching for the 6. So we set the P to H. So now we have the P referring to the same thing that the head reference was referring to, that first node. Now we'll do our loop. While P is not null, that's true because it's pointing to the first node. And we'll enter the body of our loop. If the value in that node is equal to our target, so it's not equal in this case. It's some integer in there, but it's not the 6 we're looking for. So since it's not equal to that, then we're not going to return. So then we'll go on to the next part of our loop, which is to update P with the contents of P next. So the reference of the node that P is referring to, that next reference. So now is the memory address of the second node. Go back to the top of the loop. Is P not equal to 0? That is true. So we go into our while loop. Is p of x equal to our target? Nope. So we skip the return, and then we go on to p, set to p next. So the top of the loop, is p not null? True. Is p of x equal to t? True. Because remember, we're looking for 6. Our target is 6. Our node has the 6. So we return true, algorithm's over. We found it. True. It is true that we have found it. Now, one last thing we want to test to make sure our algorithm works. Let's look for something that's not in the list. Something that's not in the list. So let's say this is 7. Let's say this is 4. Let's say this is 2. And we're going to search for 1. Okay. First things first, in our algorithm, we've got our p reference initialized to the head reference. So is p not equal to null? True, because it's got the memory address of the first node. Does its x integer contain what we're looking for, the 1, our target? No. So we skip the return. We go to p, set to p next. Go to the top of the loop. Is p not null? True. Is the x integer equal to what we're looking for, the 1? No. So we skip the return and go to p next. Go to the top of the loop. Is p not null? True. So check the contents of that node. Is px equal to our target 1? No. So we go to p, set to p next. Top of the loop. P not null? True. Is px equal to t? Is that 2 equal to our 1? No. Skip the return. Go to p next. Right, so we set p with the contents of our next reference, which is null in this case. Go to the top of the loop. Is p not null? False, because p does contain null. So we skip the body of the loop. While loop's over, we return false, which is what we wanted to return because we didn't find what we're looking for. Okay, so in all scenarios, it works. Our algorithm is good. Now, what about its performance? Well, what are we doing? We got ourselves a loop here. So what we have to do is we have to search through each and every node. So as the list gets bigger, the searches we have to do grow bigger too at a 1-to-1 ratio. So we have to check this node. 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 So 4 nodes, 4 checks. Now, if we had 10 nodes, we'd have to check 10 nodes. Do you have the value I'm looking for? Do you have the value I'm looking for? We'd have to do that 10 times. If we had 20 nodes, we'd have to do it 20 times. If we had 50 nodes, we'd have to do it 50 times. So this is going to be an algorithm that has a big O of n, because we have to do these basic checks here in our while loop for every single node that we have. Okay? So that is the find algorithm.